So on Zoom, there is this one more facility. If you click on the participants view, and if you look at bottom, there should be few buttons like yes, no, go slower, go faster,
Yeah.
and
Raise your hand.
yes, raise your hand and so on. So if I'm asking a question and you don't want to turn your mic on and answer, you can simply answer here yes or no. I'll be able to see that. In fact, you can also put go slower or go faster, and that will give me a hint on what to do next. So probably as a check, can we click on yes?
Okay.
I just click it.
Yeah, you clicked yes. Anand?
Before this, I just tried.
Yeah, just click on yes.
Yep.
Okay. So here I have an option of clearing it out as well. So once we have done a question, we can go ahead.
But how this go faster will work?
Go faster will let me know that I have to go faster. The feedback, the feedback is closed from the human and not the machine. So just as a review, probably in the last class we started talking about data types that are available in Python, and let me quickly sort through. We talked about strings. So we talked about Booleans are simple. It's just either true or false. Numbers also we have, I think, when doing operators, we have seen most of Booleans and numbers. Strings are sequences, and we saw how to define strings, how to access strings using their indices. We also saw strings are immutable objects. We then saw lists, tuples, and sets. Lists are something like arrays that we have in other languages, but they are like it does not, a list in Python need not just have one kind of data type. It can have a combination of different data types together. They are mutable objects. That is, you can add, remove, modify, insert in elements in between. They are ordered sequences. Since they are ordered sequences, we can access them using indices as well. Similarly, tuples are ordered. That ordered means they have numbers and we can access them using numbers. They are immutable. That is, once you have made a tuple, we cannot modify it. We can create new tuples out of it, but we cannot modify an existing tuple. That is, we cannot add elements, we cannot remove elements, we cannot modify elements, and so on. We look at sets. Sets are unordered. Unordered means now, since they are unordered, we cannot access them using indices. They are containing only unique values. Okay, they are mutable. That is, you can even after creating a set, we can add sets in them. We can add different elements. We can remove elements. We can modify elements, and so on. Dictionaries is something that we have not seen. Today we'll look at dictionaries and how this works. And dictionaries are also very powerful data types that we use in Python. Okay. So. Okay, on any of the topics that we covered here in the last class, I'm quickly going through. If you see something that you need more explanation on, let me know, and then we'll stop there and we'll discuss that before going to dictionaries. Okay. So this is what we finished last, sets and certain Boolean operations on sets. We can do unions, intersections, symmetric differences, and differences. Let's look at dictionary. So dictionary is basically, it's like an address book where we can find the address or contact. Okay. So if we know someone's name, we can go to the corresponding page and find his address, email address, contact details, and so on. So here what we're doing is we are using the name as a key, and associated with the key are different values that can be used. So because of this, we should note that the keys should be unique, and because if there are multiple values that are linked with the same key, it will be difficult to extract those out. So keys should always be unique. The same applies to dictionaries as well. And we can only use immutable objects like strings for keys. So within Python we have a lot of flexibility. So we can use different things as keys. We can use numbers, we can use strings, we can use tuples, but we can use only immutable objects. That is, once the object is created, we should not be able to modify that object, and only such objects are valid as keys. So that simply says that we cannot use lists or sets as keys. Okay, we should only use strings or numbers or tuples as keys. And we'll look into some examples that will explain this idea further. And yeah, basically translates that you should only use simple objects for keys, which also makes sense. There is no point having a list as a key. Okay. So let's look how to create a dictionary. To create a dictionary, we create it this way. So we write it in first, we write it in curly braces like this. So can you name of one data type that was written in curly braces of the ones that we have seen earlier?
It's
Yes. So sets were defined in curly braces. Similarly, we define dictionaries also in curly braces. The difference is here each value, each element of the dictionary will come in pairs. Those pairs will be divided by colons. Okay. So you'll have first key, a colon, and then its value. Comma, this is element one. Element two will again have a key, colon, and value. Okay. So notice that the key value pairs are separated by colons. The pairs are separated themselves by commas, and they are enclosed in a pair of curly braces. Okay. Also remember that the pairs in a dictionary are not ordered in any manner. So in the sense that you put this first or second or third, it doesn't matter for dictionaries. So for to access elements in a dictionary, we don't access it using the order that we have put in. We access them using the key that we have put in. Okay. So the order is not inherent to the ways dictionaries work. Okay. So if you want a particular order, then you'll have to sort them before using it. That's it. Dictionaries will be that we will be using are instances objects of the dictionary class. That's good. Let's see some examples. Okay. So to create dictionary, there are multiple ways. First way is, let's say to create an empty dictionary, I say D1 is equal to written with open and close braces. Okay. And that is how we create an empty dictionary. Otherwise, we can use the dict keyword, and using the dict keyword also we can create a dictionary. Okay. Here now we'll see how to create dictionaries which are populated. So here we are saying that D1 is the dictionary, A, the string A is the key, and 3 is the value. So that is element 1. Element 2 is B with value 4. If we print D1, we can see that the entire dictionary gets printed. And if you want to see what is the type of D1, you print the type of D1, which says that it is a class of type dictionary, dict. If you just give one element, and that one element is not separated by colons, then this creates a set. It does not create a dictionary. The dictionary always has to come in key value pairs. Okay. Now, a list of tuple and a list of lists. Okay, so let's see that. So here, what we are doing is we are trying to create a dictionary using multiple ways. One way is here we are to the dict function we are passing a list. Okay, and in this list we are passing tuples as elements. And each of these tuple has two values. The first value A gets translated as key. The second value 3 gets translated as value. Similarly here also, the first value B gets translated as key and 5 gets translated as value. So if we have a list of tuples, we can use those to create a dictionary.
here also repetition won't, and again a comma B comes, it will go out.
Yes. So we cannot have duplicate keys. Okay. We cannot have duplicate keys. If you have duplicate keys, what I think will happen is the latest one, the last one. So let's say if you have given A3 and A5, then only A5 is what you will get.
Last one will get.
Last one will get. That is my best guess. But these are some things that like people, it's just if you want to test the limits of the language. But for using, you will never do something like this. It does not make any sense. Right?
Yeah.
Similarly, as we can take list of tuples to create dictionary, we can also take list of lists to create dictionary. So here also we have an outer list which has two elements which are also lists. Each of these elements have lists have two elements each, and the first element gets translated as key. The second element gets translated as value. Okay. That's good. Now we can do some more basic operations. So here, let's say we are defining D as this dictionary, 1 as key, A as value, and we can print D and we can see this. To create or to add new elements, we can directly use this syntax. Okay, we can say D of 5 is G. What that does is, if D of 5 already existed here, it will modify its value to G. If it does not exist here, it adds that value to the dictionary. Okay, so now we have a third element where the key is 5 and the value is G. We can also go and we can update the value of other elements. So we can say D of 1 is equal to G. That will take the first element and update it. So see, duplicate values are no problem, but duplicate keys must not be there. Okay. So here now we see that D is updated to has 3 elements, 1G, 2B, 5G. Now you can have only unique keys. Okay, so let's say here, yeah, this is what I was giving an example of. If I create a dictionary with 1 as key and A as value, 1 as key and B as value, only this one gets translated and this one gets ignored. Now keys have to be immutable data types only. So here we have keys as numbers, that works fine. Here we have keys as strings, that works fine. Here we have keys as tuples, and that is also fine because tuples are immutable, right? So here we have the key as 1, 3 is the key, and A is the value, 1 is the key, B is the value. Okay. But here we have an error because we cannot have a list as a key. Okay, so 1, 3 list does not make any sense for key because lists are mutable. If someone wants, we can modify this further. But if that is allowed, then the way dictionary works inherently will not work out. In fact, I would say we should not use this kind of representation also because it is not much meaningful. It's better to have a more defined key rather than having a tuple as a key. There are some other methods that we can do with dictionaries. If you want to find what is the length of a dictionary, we can use len d. So len is a basic Python function that gives you the length of different items. So this length also works for tuples or lists. It's a generic function that tells us what is the size or how many elements are there in the iterable. Okay. So here dictionary, when we do len of d, we can see that there are 2 elements. Okay. We can delete it by multiple ways. If you want to delete one object, one element of the dictionary, we say D and we provide the key of that element. And by doing that, when you say delete of this, del of this, you can see that the first element has gone deleted. Okay. Similarly, if you want to delete the entire dictionary, you can just say delete D and the entire dictionary gets deleted. Now, when you write D here, it gives you a name error, says that D is not defined. We can also run loops through the dictionary. So let's say we have a dictionary here, and if we run a loop for I in D, so the way for loops work in Python is this has to be a sequence iterable, and here the sequence iterable is this dictionary. So it runs through the elements here, and can you tell me here what does I represent? Does I represent the key or value?
Key.
Yes, so I represents the key. So when you run this iterable, you get all the keys I1 and 2. Okay. Now, if you specifically, so here we know by default it gives us keys. Okay, but specifically, if you want only keys of the dictionary, you can have some object-related functions with the dictionary object. So dictionary object has an inbuilt function called as keys. When you do d.keys, it returns to you the keys that are available in the dictionary.
Okay, and sorry. How we can know what all inbuilt functions like d.keys, d.values? How we get these details? Okay. What all things are there?
Yeah, so there are multiple ways of doing that. One way is what you can do is if you run the command dir d, what it will do is all the functions or variable types that are available in this object d, it will print those values out. Okay.
Okay.
And further, if it is an object, we can also do something called as bars of d. And both of these functions will return to us what functions or arguments or variables are there within those objects.
Okay, here help is also there, like how we should pass the variables.
Yes, you can do help of D also, and that will work out fine. Okay.
Oh.
So here, what Python does is it says that this D need not be the exact function that you're searching for. If you also pass the object, it will give you elements of that object. Probably it works. We'll have to see, run and see. So probably at the end of this code, we'll execute this and we'll see how it looks like. Even I think in last class, there were some things pending to be executed, right? We had discussed that we'll execute, but we were not able to finish dictionary.
But actually, I forgot what was my question.
Yeah, same here. Maybe we'll see
Yeah.
later on.
Yeah.
Okay. So these are certain things we can use. I would, yeah, this I would introduce in when you are doing functions. But fine, you ask the question here. We can get these answers here itself. Okay. So going further, just like we can access keys, we can access values of the dictionaries as well specifically. So if we do d.values, we can see that we get a list of dictionary values with all the values of the dictionary, and you can iterate over those as well. But sometimes we need to iterate over both of these ideas, key and item both. Okay. So what we do here is we use d.items, and d.items returns to us this. Okay. So this is a list of what? It's a list of tuples, right? It's a list of tuples, and each tuple comes with a key and value. Okay. So if you remember when we had discussed tuples, when you are iterating through a list of tuples, we can do tuple unpacking here itself. So here, when we run through a list of tuples, we get I and j. I will take the key, j will take the value. Okay. So both elements are now accessible inside the loop by using d.items, dictionary.item. This is a very interesting way, and many a times we need to use something like this as well. It's just good to note that probably sometime in the future we'll be using this as well. So even with dictionary, we have concepts like shallow copy and deep copy. So a demonstration of that is this. Let's say D is this dictionary, and we say D1 is equal to D. So at this point, what we have done is we have done a shallow copy. Shallow copy means that D1 and D both represent the same dictionary, both represent the same elements. So when you print D1, we get, okay, we can see the values are same. If we modify D1 1 as C, we can see D1 as modified, but we also see that D is also modified. Whereas when we do a deep copy, this can be done in two ways. One is we can do d.copy, and D is the original dictionary. It has an inbuilt function called as .copy. We could have also created a deep copy by doing something like this. If we write D1 is equal to dict.d, okay, and that would be again a deep copy. And in deep copy, even when you modify D1 and we see this is gone to C, D does not get modified. So just something to note. We have other functions that we can use with dictionaries. Let's say we can use the get function. And what this does is it helps us to get the value inside this. So you can do d.get1. It says, okay, it will go to the key 1 and it will return the value A. Okay. So you would ask that what is the problem we could also access this by doing something like D1, and this would also give us the same answer, right? But let's say we do something like this. We are trying to fetch an element that is not present in the dictionary. This returns to us a value none, whereas D5 would return to us key error. It will say that D5 does not exist. Whereas here get5 does not return an error. It returns a value called as none. In fact, if we want to return a generic answer instead of none, if I want to return that if I don't get an element with the key that I'm asking for, if I want to return a default value, you can do that by passing it as the second parameter for the get function. So here, when you search for D5, it returns to us no key. This happens when 5 does not exist as a key in the dictionary. So sometimes this is useful. That is, if we just want to fetch items from a dictionary, and we are probably not sure if that item exists, then we can return a default value instead. Sometimes. So again, a useful function that works out many times. Then we have the update function. It works like this. Let's say D1 is defined like this, D2 is defined like this, and we do something like D1.update D2. What this does is it concatenates both these dictionaries together. So now when you print D1, we see D1 has the first two elements it already had, but now it also is updated with the elements of D2. Okay. So when you want to add to dictionaries, you can do something like this. We can do D1.update. Now to remove elements from a dictionary, we can use the pop function. Pop function, the difference between pop function and delete function is pop function will remove the elements from the dictionary. At the same time, those elements will be accessible into another variable. Whereas delete function will simply delete it. You will not get it as an output. So here we have two items, 1 and 2. And when we do d.pop1, what it does, it takes this first element and pops it out of the dictionary. So you get the value A outside in K. And if you look at D, D has only one element now because you have already popped the first element. Okay. So here 1 does not represent first element. 1 represents the element with the key as 1. Okay. Similarly here, let's say we have D and we try to pop out 5. 5 does not exist. We also pass a value no key. So if it does not exist, the default value of no key goes into K and D remains the same as before because since 5 is already not there, how can he remove it? Similar to list comprehension, we have something called as dictionary comprehension. So it goes with exactly same idea. We want to create a dictionary by writing this piece of code. And how this works, how do we tell that we want to create a dictionary? By passing this into curly braces and writing the return value as a key value pair. So we are saying that create a dictionary, and in this dictionary, we would have keys like y and values like y square, y into 2, sorry, 2y. Okay. And where should this y come from? It says y should come from this for loop. It say for y in range 5. So range 5 means it will take values as 0, 1, 2, 3, and 4. Okay. So it will take these values for y. And when you look at the elements that we have is we have 0 and 2 times 0, 1 and 2 times 1, 2 and 2 times 2, 3 and 3 times 2, 4 and 4 times 2. Okay. So we have something like dictionary comprehension. Again, this is also very useful because sometimes we quickly want to create a dictionary that can be used. And those are places where we use this dictionary comprehension. Now, how to update elements in a nested data type. Okay, so let's look at nested data types here. Here we have X as a dictionary. This X has two elements. This is our first element, and separated with a comma is our second element. The first element is a key value pair where the key is A and the value is a list of three elements 4, 5, and 6. The second element is also a key value pair. The key is B and the value is a tuple. Inside that tuple are three elements 11, 22, and this third element. The third element is a dictionary which has a key of C and a value of 9. In real life, no one in their right mind will create something like this. But here we are creating it so that we can just demonstrate what other functions, what things we can do with dictionaries. Okay, so a dictionary is a very complicated dictionary. It looks like this. So now, if you want to update this value of 5 to 55, how we can do that is we can access this using something like this. We can say X is the dictionary, X of this part. So X of A gives us the value, gives us access to this entire value. To this entire value, we want the first element. So this 0 element is the first element. We now have access to this element. When we update that to 55, we can see that the final value also gets updated to 55. Similarly, in this case, if you want to update the value of 9, the way we'll do that, we'll say is X of B gives us access to this tuple. Within this tuple, 2 gives us access to 0, 1, and 2, this dictionary. Within this dictionary, we take this key as C, which gives us access to this value. And now we can update that value to 19. Okay. So you see, everything works in a chained fashion. So we go to the closest element that we want to reach and then, access elements using a chain kind of structure. And that gives us access to this element. We have updated it to 99 and we can see it gets updated to 99. Okay. So this is our basic ideas about data types. Probably before going ahead, I'll share a poll. Try to answer these questions. So,
Okay.
yes, you should see a poll on your screen. A very basic poll. Try to answer it the best you understand. Yes,
and I
done.
just
Yes.
small doubt. When we type dir of some set of some parameter, we get a big list.
Correct.
How we know how we should pass the parameters into that?
I'll share my screen now, and then we'll
Yeah.
probably that will be a better example. Right. Are you finished with the poll?
Yes, yes.
Yeah, I have some. Yeah.
You both of you have submitted, is it?
Yes.
Yeah.
Oh, I'm not able to see the. Comments. Okay. Just 1 second.
Yeah.
Okay. Since I'm not able to see the results, can we quickly discuss which of these is not a core data type? So list, dictionary, tuples, or class. The answer to that is
I put class.
okay.
Class. I have put class too.
Right. Class is not a core data type. Class is like a user-defined data type. So if you want to define something on our own, we can use class. So which is the right answer. Then there was. You're able to see the questions now.
Yes.
Yeah.
Okay. Somehow, I think since I'd as a
It is the
trial,
results.
what
It is the results, right? Oh,
you're able
set.
to see the results also. You're able to
Yes.
see. Oh,
Yeah.
Yes.
strangely, I am seeing only 0. That is, no one has answered in a sense. Okay. So okay. So then the second question, the answer should be HE, right? Hello. Hello.
Yeah.
What that is.
Yeah. Hey. Hello.
Yes. Yes.
Yeah, we
Hello.
can hear you.
Okay. Okay. For the third question, what data type?
Is a list.
Yes, and the answer is list. Okay. For the fourth question, the answer is
Third one, X.
yes, X star star asterisk asterisk Y.
Yeah.
And fifth question, true or false?
Uh, false.
Hmm.
And
That's true. Fourth question is false. Okay.
okay.
So strings you can to convert, like if you have numbers as strings, you have to convert those into integers or floats, and then you can operate mathematical operators. By default, when you operate mathematical operators on strings, it will do concatenation, joining, and things like that. It will not do true mathematical operations.
Okay.
So I'll close this. I'll share my screen here.
Oh, this is how it looks.
Yeah, this is how you create the pool. Strangely, I don't know. I'm not able to see values. Okay, we'll see later.
I'll test it later.
Yeah, we'll test it later. So the I think we did not have last time we also did this. So I'm guessing we would have solved questions regarding this. This is what an example of dictionary looks like. So I create a random dictionary, and if I want to see what elements are there within this dictionary, I can use something like DIRD, and it gives me the object inside. So there is clear copy from keys get this. You're saying your question is, let's say I don't know how to use from keys.
Yes.
Okay. Then I can go further and do a help. I can do help of d dot from keys. And when I execute this, it gives me this small help. It says help on built-in from keys. Create a new dictionary with keys from iterable and values set to a value. So
That underscore what it is above clear.
So yeah, these guys. So underscore
Yeah.
underscore is generally a way of setting a value in something. So let's try this one out. Okay. So if we do d dot underscore underscore len underscore underscore. Okay, and you execute that, it says okay, this is a method wrapper of this object. If I want to know more, I can do help of this, and it gives me something like this. So generally, whatever you find with underscore underscore is something that we do not use. Okay.
Okay.
So these are inbuilt wrappers that Python uses to do some internal operations.
Right.
So here are final operations like keys, items, values that we generally use. And to make these things work, this class of dictionary would have come from another base class. And for those base class, certain functions must be defined. and those are generally defined using this underscore underscore name underscore underscore. So very rarely we will have to use these values. Most part we'll be very good with these case. Okay. There's also another function. If you do d dot and you press tab within the Jupyter notebook, you should see a list like this. So it gives you things that you can reuse within the D object. Okay. So let's say D values, and then when you execute this, you can get the values. Let's say there are certain things that we need to pass parameters. So let's say D dot get, and here you need to pass parameters. You don't know what parameters are allowed. You can press Shift and Tab. When you press Shift and Tab within Jupyter Notebook, it gives you this small pop-up window, which gives you an idea of what is required. So it says that the get function can take two values. The first value is a key, and it says return the value for key if key is in the dictionary, else return default value. So by general, default value has the value none, unless you specify something else. So if you want to take a function and you want to know more about it, you can go into the parentheses of the function and press Shift and Tab. Okay, that will give you this list. If this list is bigger, you can press plus sign, and you can read more of this material. Okay.
Yep.
I have also attached the assignment for the next class. Sure.
Yes, we got it.
Maybe we can discuss one of those questions. Okay, so this is you have already seen, but we have not seen functions of the type dictionary, right? So something like this. Okay. Should we discuss this, or you guys want to try it out and then maybe later we should look into it? What do we do?
Anything is fine actually.
Universe?
I think we will try first and then.
Okay, sure. So you want to try one of these or directly the dictionaries? Maybe, okay, choose a number that we should try out and then we'll just give me 1 second. I'll just come back. Yes, tell me. Srinivas?
Yeah.
Yeah.
Here.
Oh, you're still reading, is it? Okay.
Yeah. Yeah. Let's go with the 8 then. Right?
8-1?
Great.
Yeah. Okay. So I'll just copy this. And just paste it. I'll convert this into a markdown. Okay. It says write a Python script to generate and print a dictionary that contains numbers between 1 and n in the form x squared. So sample dictionary n is equal to 5 looks something like this. Okay. So here for something like this, we can use list comprehension, dictionary comprehension. That would be the easiest way to do it. Or we can create a for loop also. Let's do it by both methods. Maybe we'll do for loop first and then see how this works out. We can take n from the user. We'll say int of input, enter a number. Hopefully the user enters a number, and then he'll say for I in range n. So we have to start from 1. Okay, so 1 till n. So we have to do n plus 1 because the range function goes 1 less than the stop criteria. So we do n plus 1, and maybe we start with an empty dictionary. We say d is equal to an empty dictionary, and then simply here we write d of I is equal to I square. So either I times I, that should work fine. And we just print D. So let's say enter number 5. It turns to us this value. Okay, another way of doing this would be, let's copy it, paste it here, and we'll do a dictionary comprehension, which says D is the dictionary we are creating. Return I times I as key and I times I as value for I in range 1 to n plus 1. Sorry, 1 comma n plus 1. And so here also we should get the same answer, right?
Yeah, got it.
So Python generally is pretty simple to handle with. The commands are simple. The language is very intuitive, and there's loads of help available. So let's say if you get stuck here, we're not able to do something. You just put a question in Google, and it will help you, sort things out, understand the concepts, and then come back and work on it. Maybe we can continue with probably the next topic of functions. We'll at least start it, and we'll see how much we can go uh, along with it. Is that fine?
Yeah. Okay.
Or yeah. Okay. Okay. So functions are very key elements within any programming language, and the basic use of functions is to take small pieces of code that we generally would be requiring to use again and again and again, and we take those pieces of code and we plug them into a set of functions, set of instructions, and those are called as functions. And the primary use is for something called as abstraction. And what do we mean by abstraction is we take complicated ideas that would probably make our code not user friendly, and we add them, put them into functions. So once we have abstracted something, so let's say if I tell you that we have to write a function to find something like NCR, okay, and we know NCR can be evaluated by n factorial divided by r factorial times n minus r factorial. Now, to evaluate NCR, we see that we are using a key term as factorial. And if I'm writing a piece of code and I write the entire factorial thing, and to generally implement a factorial, you'll need to have to run through a for loop. I have to have that for loop 3 times with 3 different uh, parameters, one for n, one for r, one for n minus r, and that would make my code look very clumsy. Better way is I can write a smaller function for factorial, and then to get NCR, I will just use this function 3 different times with different parameters. That would probably make my job easy. And additionally, when someone reads this code, his job is also easy because they can understand that code pretty well. So the primary reason that I think function is important is for a concept called as abstraction. You abstract, you take a bigger idea and you write it in terms of smaller ideas. And you do that by abstracting the primary logic away from the way we read the code. Okay, we do this all the time. Let's say if you want to write Ohm's law or something like that, we say Ohm's law is equal to V is equal to IR, or your resistance is V by I. And this is a tool that we use many a times in circuit analysis and things like that. But we say that this tool comes from Maxwell's equations. We will not always go back to Maxwell's equations, derive Maxwell's equations, do the calculus part, find out, take a small area, integrate it, differentiate it, and then comes to Ohm's law. Once we have defined a logic like this, it is very easy for us to use Ohm's law. Okay. Similarly, when we talk about functions, once we have defined a smaller part and we know very clearly how the small part works, we need not go inside the specifications of how factorial is working. The focus now remains to use factorial in different tasks. Okay. So far we have already used so many of the inbuilt functions. Some functions in Python that we have already looked at is we have looked into the print function, we have looked into the range function, right? And these functions, we probably don't understand how these functions work internally. I don't know how the print function works, how it takes values, how it converts those values into pixels and puts material on my screen. I don't know how this works, but still, if you tell me to use the print function, I can use it pretty well. Similarly, I have no idea how the range function works, uh, how it takes different parameters, understands the first as start, second as stop, third as step, and so on. But similarly, even without understanding how it works internally, if you tell me to use it, I can use it pretty well. Okay, so those are ideas that we get with functions. Okay. Let's look at what we look into functions within this class. So we look at function parameters. What are the different parameters? How do we define parameters? And the way parameters are understood within Python, there are ways of manipulating those and using those in different ways. We can use default arguments. We can use keyword arguments, variable arguments also. And these are some things that provide a lot of power to us as users when we are using functions. Okay. Then we talk about the return statement, how the return statement works, how we can use functions to return different values, and can we return multiple values, can we do packing, unpacking, and so on. We'll discuss those things. We'll look at the difference between local variables and global variables. And then we'll look at three key functions that are very useful in Python. So these are functions like lambda, map, and filter functions, which require basic initialization, and we can use them for very simple tasks. And then finally, we'll look at how to create professional functions using docstrings. So most professional functions will come with a very good documentation, and how the documentation is loaded and how we can do that for our functions, we'll look into that in docstrings. Okay. So functions are basically, as I said earlier, they are reusable pieces of code. That is, once we have defined a function, we can reuse them multiple times. They allow us to name a block of code to give statements allowing you to run that block in a specified time. Okay. Yeah, so it basically takes a piece of code which you can assign a name to, and once you have assigned a name to it, we can call it multiple times. The function concept is probably it is the most important building block, which is very true, and I agree totally to it, because there's absolutely no language that does not have functions inbuilt, and it's a key way of how we write code in most of the time, especially when you are having big pieces of code to write. It is very easy to divide that into series of functions and then define those functions. Okay. So functions in Python are defined using the def keyword, which stands for definition. So we write a function by saying, we start a function by saying def, which says that what follows next is the name of the function. Here then followed is the name that we will be giving to the function. The parentheses here define what are the inputs that the function will take. We will take a series of arguments given by certain names, and we'll separate that using commas. So here this function's name is say hello, and this function takes two arguments. The first argument is name, the second argument is sname, which stands for surname. Okay. We end this line with a colon saying that, okay, now we will start defining what the function looks like. In the next line, we will give a tab. This tabs, so as many tabs we give, these tabs represent that all these lines are part of the function. They are in the scope of the definition of the function. Okay. So here we are just writing one single line, which is saying print. We are taking the name, we are printing hello, name, space, surname. Okay. So executing that with maybe Elijah Topo would look something like this. If I give the name, the way I will use this function is I will call the function like this. Say hello. And when I call this function, the output I will get would look like this. Saying hello. Okay. Let's look at some more things. So here we are defining a function called as f1, and it takes no parameters. It has two statements inside. Both the statements are print statements. We say print hello, and then we say print, this is first program. Okay. To execute or to call the function, we call it like f1, f1, f1. So this piece of code will execute 3 times. We get 3 times the same answer. Okay. We can execute the function in a loop as well. So here we are running a loop for I in the range 5. So range, this will take 4 values, 0, 1, 2, 3, and 4. So it will take 5 values from 0 to 4. And this code simply runs 4 numbers of times and we get the answer. Okay. So we have a task. It says create 2 functions, f1 and f2, which will be called when we have even and odd numbers given from the range function. So probably quickly I'll shift to my laptop screen. We can write this piece of code, see how this looks like. Okay, are you able to see my laptop screen?
Yes, yes.
Okay.
Yeah.
So we are writing 2 functions, f1 and f2, which will be called when we have an even or odd numbers given from the range function. So quickly let us define f1. So f1 would simply say, let's say we print it to say even number. We can zoom this further. I hope this is more readable. Okay. And we can define another function, f2, that simply prints odd number. So these are 2 functions we have defined. Now we'll run a loop for n in range maybe 10, and we'll say if n%2 is equal to 0, that means there's an even number. We will run f1, else we will run f2. So when I execute this, maybe we can also, yeah, we can also probably print, and we end with space. So when I execute this, we can see 0 even, 1 odd, 2 even, and so on. Okay. So just a simple example of how we can define functions and then call them for different criteria and so on. Okay. Move back to like that. Okay. So going ahead, functions can take parameters, and in Python there are multiple ways of doing that, and we'll look into those. So it can take parameters, which provides inputs to the functions. So the first function f1 and f2 we saw, it does not take any parameters. So it's just, you just call this function and they execute irrespective of where you run it, it will always give the same output. Why? Because it does not take any input itself. So whatever is internally calculated, it will just give us those outputs. But many of the times we want functions to return different things based on what we are passing in. And that is what we call as parameters. Okay. So parameters are just like variables, except that the values of these variables are defined when we call the function and are already assigned values when the function runs. Okay. So again, they are variables that we provide as inputs, and when we assign them, when we run the function is when the values get assigned, and then we can use those in the function. Parameters are specified with pair of parentheses, and they're separated by commas. When we call the function, we supply values in the same way. Okay, we'll look into this when we look at more examples. And in the terminology, just when do we call parameters, when do we call variables, when do we call arguments, just like this. Okay. The names given in the function definition are called parameters. Okay, whereas the values that you supply in the function are called arguments. Okay, so let's look at here. So let's say here we have a function which takes 2 parameters a and b. So a and b are called as parameters, whereas 3 and 4 are called arguments. Okay, these are the values that these parameters will be taking. Okay, let's go deeper within how this is functioning. We're defining a function called as printmax, which takes 2 parameters a and b. Within the colon, that is, now all of this comes into the scope of the function. We are defining a logic. The logic is like this: if a is greater than b, we will print a and we'll say this is maximum. If this is equal to each other, we will say this is a is equal to b, and else we'll say b is maximum. So we'll just print the string depending upon what we are getting as A and B. Okay. When we pass values here, literal values 3 and 4, the first, since it follows the same order, okay, unless we go for default arguments, and which we'll look into later on, or keyword arguments, which we'll look later on. But at this point, whatever values we pass here goes in the same order. So 3 goes to the variable A, 4 goes to the variable B, and here we say that 3 is greater than 4, which is not true. 3 is equal to 4, not true. So if those two are false, the only option remains as this last one. So we get the answer as B is maximum or 4 is maximum. Similarly, we can, instead of passing literal arguments, we can also pass variables as arguments. To do that, we are creating two variables x and y, loading the value 5 and 7, and then passing those to the function. We get 7 is maximum. Now, depending upon how these arguments are passed to the function, we have 4 different cases: required arguments, keyword arguments, default arguments, or variable length arguments. So maybe at this point, you need to tell me what do we do. So we are at 8 o'clock. If I start this topic, it should take approximately half an hour to cover this. If you guys can go for half an hour, we can continue today, or we can continue in the next class. Srinivas, what do you say?
It's better we'll continue in the next class.
Sure. Then we'll take these arguments and we'll talk about it in the next class. Okay. I'll put up the assignments for functions. I think you should be able to do some of those assignments with just what we have done so far, and things that require more advanced stuff, maybe we can continue doing it next time. Okay.
Okay.
Yeah. Then we can have the next class on day after tomorrow, which is Thursday morning. Thursday morning for me, and for Srinivas, you will have to calculate accordingly.
Yeah, it's gonna be tomorrow.
Yeah. Okay.
Wednesday. Yeah.
Okay, then have a great day. Bye.
Bye.
Yeah,
Maybe I will discuss on WhatsApp the YouTube link that I've sent. Why you're not able to see it? Okay.
Okay.
I will probably share again and see.